Good morning, everyone. I hope you're feeling awesome this morning, right? And I really like those sandwiches that were provided by the facility, especially those cheese sandwiches. They were my favorite. Well, I really would like to thank you, all of you, for replying back to my survey that was sent to you, and I had certain queries as well. And some of you have also mentioned that you would like to know more about coordinate systems, right? So today our whole lecture is all about coordinate system. You all know my name, Shahrukh Wase. My email address is written here on the PPT as well as there. So if you have further queries, you can always mail me back, right? So today we're going to talk about importance of coordinate system. I also would like to mention about certain logistics. In evening when you leave the office or this area, you know there is some traffic congestion happening and certain construction is also happening. So I would like you people to take this road because it will be less congestive, right? And also, yesterday we were having certain temperature issues. So today facility has fixed that. And also please mind the wires, they are not fixed properly today somehow. So I have asked them after a break, probably they're going to fix it better. So please mind, when you're walking around here and there. So today's learning objective. So the learning objective that we're going to talk about today is understanding coordinate system in ArcGIS. So we'll try to understand how coordinate system works in ArcGIS, the types of coordinate system we have, the different type of projection that we have, and we are going to go into deep. We have so many other things that we're going to talk, bits and pieces and the nitty-gritties and the important things that are important for a coordinate system, right? So let's start with a basic thing, that is, what is location? Anyone would like to answer that for me?
Name of a place.
Name of place. Someone else? Oh, that's great. Okay.
It's a reference.
Yeah, it's a reference. Great. So, to understand location, let's do a small activity. Vishal, do you have a cell phone with you? Okay, can you please take out your cell phone and open the compass, and can you please tell me what exactly do you see there? Even I have a compass in my cell phone. Smartphones are really smart these days.
It's showing me the location.
Yes, in form of numbers, right?
In form of numbers.
Even my cell phone shows the same, and your and mine is same. You know why? Because it's the same location of this area, this region. Now, to understand location, basically, on the image, if you see here, there's a red dot which says read length. So for some person, as Sriram mentions place, it's a reference location for me. So basically, for some, this read line would be 45 minutes past west from Past Springs. For some, it will be UTM zone 11. For some, it will be east of Los Angeles. For some, it will be a number, something like that, in the form of lat long. So basically, if you see as a whole picture, there are two kinds of location that we can refer to. One is relative location, and another is absolute location. In relative location, we try to relate things, right? We are giving a reference to something. But in absolute, we look for exact latitude and longitude, right? So that's what exactly you were getting in your cell phone. That was, you people also can see it when we are done with the session. You can also open your cell phone and you can see and check compass, right? So let's try and kickstart and understand more further about coordinate system and projection. Let's start with basic definition. So let's understand how the definition says. Set of numbers, right? Set of numbers that allow for the determination of the location of Earth. There's a set of numbers that allow the location of the Earth. Now projections. Projections are nothing but the transformation from the curved surface 3D Earth to a flat 2D surface. So what is happening basically, this 3D, 3D when it goes on to the 2D platform, that's what we exactly call as projection. So in the meanwhile, I have small thing for you people. We are going to do a very small activity. Quickly, Sriram, can you please distribute these chits to everyone? So we are going to do a small activity. I am going to draw something here, and you have got points there, and you're going to plot them here. So who would like to come first? Okay, I see so many hands. You people seem like very excited, huh? So before, oh, that's great. Okay, hold on. Let me draw this for you, and then people, you can come down. You can count the dashes and you can plot. I hope you recall all this because you all have done in your 9th, 10th. Oh, great. It's cool, cool. So, Sriram, you can try first.
Yeah, sure. Thank you.
Then who would like to come next? Oh, come, come, come. Oh, great.
3 and 4.
Come, come, come. Come one by one. Just plot the point and give me the chits. You can keep the chits here.
Okay.
Thank you. Yeah, please come, come.
After a long time, I've done this.
Oh, that's great. Neha, you don't, doesn't seem to be exciting about it. Oh, oh, great, great. Oh, no issues. Thank you. So, Raja, you are the last one. So, yeah, you may please take your seat. Please mind the wires. Yeah, thank you. Okay, so what exactly you have done? Can anyone tell me what exactly you have done right now?
We have just plotted the points based on the numbers you have given to us.
Yes, and that those numbers were some were positive, some were negative, right? So this is a Cartesian coordinate system, right? And we have placed it on a 2D plane, right? It's a 2D, right? It's not 3D.
Yes.
You're absolutely right. So let's try to understand the coordinate system. Coordinate system is nothing but set of numbers that allow us to determine the position of a point in an empty space, right? Exactly. It has lat long x and y. So that's what how spatial data storage happens. Now, as we discussed in the initial session that we are going to talk about more about projections and different kind of things. So this is geographic coordinate system. This is first kind of coordinate system that we are going to talk. So geographic coordinate system is nothing but a reference based on 3D spherical surface. So you remember that sphere that is kept there, right? It's a basically nothing but a reference of this on a 3D sphere. And the angular distance is measured on the basis of latitude and longitude, and when you do the measurement, it is always done on the basis of two, that is degree, minutes, seconds, and decimal degrees. You also notice, what do you see here?
The lines.
Yeah, these are what? Yes, latitude and yes, latitude and longitude, and also it has prime meridian. It has got datum also, which is nothing but a unknown control points that are used for the reference-based system. So let's try to understand the second type of projected coordinate system. This is the second type. So the second type basically is nothing. It's a reference based on 2D. When we try to project, when we project the 3D onto 2D, when we reference something, so that what exactly the projected system is all about. Now, when we say globe, things become a little difficult. Vishal, where do you come from?
Delhi,
Rohini.
Rohini.
What about Raja? Where do you come from?
I'm from Gurgaon.
Gurgaon. Okay, you're Gurgaon. Vipula, what about you?
Chennai.
Okay, Chennai. So now imagine if I have to calculate the distance from Vishal's place to Raja and then from Raja to Vipulu. How would I do that? Can I do that on a globe?
No.
How can I do that?
I
I have to be on plane, right? Yeah, that's why we do that. And when we are talking about plane, so the measurement units are of a plane? Exactly, absolutely, great. So what I want you to do small activity, open a laptop. I have loaded one bookmark on your system, on your systems, and you just open that link, and it is also mentioned on this website here. So open this and just have a look. I want you to visualize more.
So that is pretty interesting.
Ah, you like it?
Yeah, I really like it.
Yeah, so you can see the transformation that is happening. Sriram, did you find it amazing?
Yes, very great. So it's changing shapes.
Yes.
Representing.
dynamic one. I really like.
Oh, that's great, that's great. So that's how basically, projections happen. That's how projected coordinate system works. Now, let's talk about the projection. basically there are three types of developable surface, developable surface that happens. So the three types are, first is plane. So when you try to project from a 3D on a plane, that's what exactly this happens. Can you see the image here? Right, that's good. Now, the second type is conic projection. Now what happens is, when you try to project with the help of a cone, can you see something here? Yeah, that's great. Now, when we go for the third type, that is cylindrical projection. When we try to project with the help of a cylinder. So can anyone tell me, what you see here? Is something changing? What is changing? Great. So to understand this, I have a very small video, and we'll go to that, and let's see how you understand it more further. It's a very small video. It won't take much of a time.
Map projections can come in all sorts of shapes and sizes. These shapes are flattened into a two-dimensional paper map or digital dataset used in Geographic Information Systems, or GIS. But no matter what shape is used, the resulting flat surface is distorted. That's why there's no such thing as the perfect map projection. For example, using the Mercator projection, Antarctica appears to be a huge continent that wraps around the Earth, and Greenland appears to be just as large as South America, although Greenland is actually only about 1/8 its size. The GIS user must decide which distortions are less important than others, and then choose the appropriate map projection. GIS software such as ArcGIS can take the data and metadata and overlay each dataset in the desired projection, enabling the user to be productive as quickly as possible.
Oh, that's great. Did you enjoy the video? Yes. Was it interesting? Yes. That's great. So, so we were discussing about the properties, as you can recall from my previous slide, right? Did you see this, that the changes that were happening? That were happening because of all these four things, that is shape, area, distance, and direction. Sometimes it becomes a little difficult for me to remember, but I just take the acronyms, that is SADD, SAD, but it doesn't make me sad. You all are GIS analysts, right? So, it doesn't make us sad. Projections are good. Also, I forgot to mention, I see one question in the parking lot. It says, what do you mean by UTM, and what do you mean by UTM? We are going to take this question for sure in the upcoming slide, and it will be more logical. I'll tell you what is UTM. So when we talk about shape, area, distance, and direction, somehow whenever we project from 3D to 2D, we somehow compromise on any of the properties. Sometimes we try to reserve the distance and direction, but you lose out on area and shape. Sometimes you preserve shape and area, and then you lose out on direction and distance, right? So it's somehow the permutation and combination that keeps on happening all the time. We'll also try to understand with the help of a demo that is in ArcGIS. You know what is ArcGIS? Yes. What is it? ArcMap? Do you recall something? Exactly. So we are going to I'll just take you through the demo, and you'll understand it better. So what I have done, basically, for your convenience, I have done certain transformation with a single shapefile. As you can see, the shapefile is common here, country, 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 and also if you notice properly, the data frame says it's Mercator. So someone also asked me about UTM. So UTM stands for Universal Transfer Mercator. It's one of the transformation from this. It's the name of the Persian basically, so it has been named after him. So it's nothing but one of the type of projection. Also, if you see properly here, this Lambert conformal conic, which is again a different type of projection. Then there is one file which is unprojected. So for your convenience, I have already transformed them. I will also show you how we can also do that. So let's take a walk through how things change when we go from one projection to another, how transition happens, and how actually in reality it affects. So let's first of all go on to unprojected one. Can you see the whole globe, right? The whole Earth. Whole Earth. It is on the flat Earth. I mean, obviously it's not globe, but then it looks flat, right? Now let's try to go on to the Lambert. Now, what did you see? What happened? Yes, distortions. Okay. Someone else would like to add something more? Yes, very good, Sriram. Now let's go on to the Mercator. Did you see what happened? Yes, the area got changed. The size, yes. So somehow or the other, as now you can relate the four properties that I was talking about. Somehow or the other, you're compromising. It depends on the person to person what exactly he wants and what exactly doesn't want, and what he wants to achieve out of it. As being a GIS analyst, the major thing that you would like to know is which projection I am interested in. Once you know, you just need to tell the software that this is what projection I am interested in, and the maths that I've been talking about is done for you. You just need to select and run a simple tool, and you can do that. Also, this reminds me, I can in fact show you the tool that it does for you. See, oh great, okay, I have already written project. You know this toolbar? What is it? Search. So I want all of you to go through this toolbar. This is very effective toolbar, and it helps you to allow to read about all the tools that are available in the software. So you just simply need to type the keyword that you would like to know about it. So I've just written project because I need to project it. I'm going to select project, the data management. So, you know, the beauty about this software is, you all are well aware, the moment I'm going to drop down, it is automatically going to select the layer that is not projected. So right now what I'm exactly doing is, you see the unprojected layer on the image, right, the data frame. So what I'm going to do is, I'm going to select it, I'm going to project it. I'm going to provide a projection to it. Projection means I am reprojecting. I mean there is a thing which is not projected, and I'm going to project it on a 2D plane, right? So I've selected the country, and then this is my output, right? Here you go. So we were discussing about two kind of projection coordinate system. So this is geographic coordinate system that we have covered. This is projected coordinate system. So we are going to select one. We can take okay, someone wrote this UTM, so we can take UTM. So UTM is under projected, as I have discussed. Someone has developed it and we have named it after. Let's consider it as one of the thing, datum 73 UTM zone. And then you go and you just simply go ahead and click OK. Now, okay, I need to close this. Can you see what has happened? The size and shape and everything has changed, right? See, it has come into one strip. So that's how this tool is very effective. You can always use it for your projects whenever you're trying to project or whenever you're trying to change the projection onto a system. So that's how basically you work with ArcGIS, with coordinate system. You can also, you know, as I was showing you different kind of projections, you remember the two categories? So you can select any kind of projection from that, and you just need to choose. And as I was telling you, the tool that ran right now in front of you will do the math for you. So you don't need to worry about it. So before I go for the lesson review, can anyone please tell me what did we learn today?
We have learned different projections, different coordinate systems, and different distortions.
Okay, okay. Can anyone help me recalling?
Shape.
Great. Great. It means.
It doesn't make me sad.
Okay. Okay. And also, you know, when we were doing this, I forgot to connect the dots. It basically, when you try to connect the dots, it becomes a shape, and the shape has a reference on a 2D plane, right? Does it make sense?
Yes.
Yeah, that's great. So that means you remember the SAD.
Yes.
You have understood how the projection works. So that means the SAD doesn't make you sad. So you are happy, huh? So that's great. Good. So I have certain questions, and let's also check furthermore that you actually remember. things or not. So first question, is it true or false? Some coordinate system preserve all the 4 properties while other distortion more? True, that's great. You open a map document to find the layers do not line up properly. What might be the indication?
Different projections.
Oh, that's great. Very good, very good. So, people, we are done for today, and we are going to take a small break. And after 15 minutes of break, we are going to start an exercise, an intensive exercise on coordinate systems so that we can understand it better. So, let's take a small break, and we'll be back after 15 minutes, right? Thank you.